So, welcome to our channel Electronics on Wheel, and thank you for your support. Please like, subscribe, and comment if you like the content of this channel. So, today we will discuss a very small system, that is horn system. So, if you like the series of this particular subsystem description where we are going to discuss about these points, so we will start making small systems like headlamp, then starting and charging system, which we have already made for the starting and charging system, but we will make for the wiper, HVAC, and other stuffs. So if you like this particular series, please like, subscribe, and comment. So today we are going to discuss about these content of horn system. So first is we will discuss about the function of the horn system, followed by the component, what are the components involved in the horn system. Then we will try to understand the working principle, where we will discuss about the wiring diagram or the circuit diagram or block diagram of the horn system. Then what are the technical specification of the horn system, like on what voltage it is going to operate, what is the frequency, and how much decibel is allowed. Then we will see the component location in the car, where they are located and how they are placed in the car. Then followed by that, we will see the function and fault of the component, where we will try to discuss about what are the symptoms if the particular function is not working. Then on vehicle inspection, symptoms and fault diagnosis. So these are the topics we are going to discuss in today's. So first, as you know, the function of the horn system is to remind the pedestrian and other vehicles to pay the attention to the safety, to avoid the unexpected traffic accident. So horn plays a very critical role when it comes to the safety. So this is the basic function of the horn system, to aware the surrounding or the pedestrian or other vehicles to pay the attention. Let's move to the components. So what are the components involved in the horn system? So first is low horn, high horn, horn switch, fuse, relay, and many other component like wires, terminals, and other stuff. So wiring harness is also one of the part of the component of the horn system. So what does it mean, like high horn or low horn or high horn? What does it mean? So a high pitched horn will have a shorter wavelength and higher frequency, so resulting a more piercing sound. On other hand, low pitched horn will have a longer wavelength and a lower frequency, producing a deeper and more resonant sound. So pitch of, for example, 400 hertz if we take as a lower pitch, then 500 would be a higher pitch. So mostly you will see in most of the OEM we use the two horn. One is the low horn, where we are using the low frequency, and other one is the high horn, nothing but the high frequency. So this is the combination. You can see the location of the horn as well, and when you press on the steering this particular horn, and inside this is the, we call it clock spring. So this is the clock spring. So this is these are the component of the horn system. Let's move to the block diagram or the working principle. So as you can see here, this is the battery power supply. So from here it will start the battery power supply. Then we will come to the fuse box, where we will be having the horn fuse. So this is a 15 amps of the fuse. So already I have told you that how to select the fuse for the particular system. Then we have the horn relay. So this relay is used to switching function of the low horn and the high horn. So one side would be the coil, this is the coil side, and this would be the load side. Load is nothing but our horn. Then the coil side will be controlled by the horn switch, and this horn switch would be a part of the clock spring. You can see here. So this is the clock spring, and inside this is the your horn switch. So this horn switch is grounded, you can see here, and low horn and the high horn, this side is also grounded. So what will happen actually? So we will just discuss about this thing, that what happens when you are switching. So as per this block diagram, we will see the two cases. So first, when the switch is off. So if you see here, the when switch is off, then there will not be any current flow, because this particular switch is off. Then your circuit is not complete, right? Because you are not getting the ground. However, you will be getting here 12 volt. Here also you will be getting the 12 volt. But you will not be, completing this circuit because it is not connected in the first case. Correct? When the switch is on. So in this condition, what will happen when you are pressing this switch, right? Then this particular uh, switch will close and this circuit will be completed. Then current will start flowing in this, right? Then this is the coil part and this is the load part, right, in the relay. So coil part, once the current will start flowing, then magnetic field will start generating in this, and this lever will contact to this one. Once this lever will connect to this one, then here also you will start getting the 12 volt. Once you will start getting the 12 volt or the power supply to the low horn and high horn, then horn will blow or horn will sound. So this is the basic, understanding or working principle of the horn. But you have to always, have to have the understanding where would be the 12 volt and where would be the 0 volt. Then only you can diagnose your circuit or your fault in your vehicle. So if I am asking in the switch off condition, when your switch is off, moment, when your switch is off, then on this till this point the voltage would be 12 volt, but here it would be 0 volt. Here it would be 0 volt, correct? Because this is not the connected, this is open, right? So till here it will be 12 volt on this wire, here 12 volt. If you have any confusion in this, you please comment in the comment box, so I will again explain this point. Then when switch is on, right, then this will make the connection, and here it will become the 0 volt because it will make the connection and it will go to the current will flow into the circuit or ground. So this is the basic principle of working of the horn system. Let's move to the second, that is the technical specification. So technical specification, if I talk about the horn power voltage, it varies 10 to 14 volt, but it depends on, you know system. So it can vary to 6 volt to 12 volt as well. So if you are using only single horn, right, sometimes some vehicle use the single horn as well, so only 6 volt is sufficient. If you are using the two horns, like low horns and the high horns, then you need the 12 volt. So there are two types of horn. One is the disc horn and fanfare horns. So I have just given the, basic overview. There are many types of horn, but you just understand what is the disc type of horn. So this is the basic element of the disc horn, that coil you will be having, then core you will be having. This is the armature, then diaphragm and vibrator. In this fanfare horn, that this is the extra part, which is the drum. Okay, other than this chamber will be, of course the new construction is there, then it would be an additional point. Then armature and diaphragm and vibrator part would be the more or less same. You will be having the coil, then core and air gaps, all these things would be same. If you see the structure wide, so this is the disc horn, and you will get some of the differences in the frequency as well. So if you see here, in the disc horn also there are two types, like standard and the 3 point mounting. So in standard only single point mounting is there, and second is the 3 point mounting. In standard, if you are using the single horn, okay, then you need only 6 volt. If you are using the two horns comprising of one high tone and one is low tone, which we have already discussed, high and low, then you will be using the 12 volt. Then similarly for 3 point mounting also, the only difference in, when you are mounting your horn, it will be on single point mounting, and it would be a sorry it would be the second one would be a 3 point mounting. So this is the difference. And if you see the frequency, so 335 to 420 is the frequency which is ranging, but when it comes to the 3 point mounting, that is 335 frequency. So I will give you this data sheet in the Telegram. You can join the Telegram. I will give the link in the description. So you can go through the data sheet of this particular horn. This is from the Bose. So this is the type of disc. That's why they have given the disc type of horn. Then we move to the fanfare horns. So you can see this is the part of, like we were discussing, the trumpet part. So this also have some advantage over the disc horn. So up to 10 times longer service, and you can see the frequency range also 420 to 500, and this is the part number. Then two sets of horn you will be having, one for the high and one for the low, and the operating voltage is the 12 volt. So this is about the fanfare horns. Let's get some of the questions which are asked in the interview also. So first question they ask, like, what is the meaning of high horn and low horn? So I already told you that what is the difference between high horn and low horn. So if oscillations are slow, frequency uh, os- uh, oscillations are slow, then frequency is low, and the it will result in the deep tone. If the oscillations are rapid, then frequency is high and the high tone is produced. Correct. But when it comes to the wavelength, so frequency generally is inversely proportional to the wavelength. So short wavelength means lot of waves, high frequency, high sound. Long wavelength means fewer waves, low frequency, low sound. This is the thing you have to remember. Then the sound pressure and volume is measured in the dB, right? So as per the ECE standards, so all the audible warning devices to have the sound pressure between the 105 to 118 dB. This is the standard, and all the Bose horns, even all the companies follow these standards. So whether ECE standards or SAE standards, so all these standards need to be followed. So these type of question can be asked, that what is the range of the horn which is allowed as per ECE standards. So 105 to 118 dB is the range. Let's move to the next, that is uh, component location. So component location, as you already know, so first we'll start from this, that is clock spring. You have already seen this. Then you have the second one is the horn switch, which is we put press this horn switch and then it goes to clock spring. Then third is the horn relay. This is the horn relay which is placed in the fuse box, and this will be the fuse from the battery. Then we have this horn, high horn and low horn. As you know, that two horns will be placed. So this is the component location in the car. Then function and fault of the component. So the part name, that high horn. So basically it provides the loud horn sound. Then suppose common fault, it might be damage. So horn, what would be the fault system for this symptoms? Then horn sound is low and deep. This would be the fault symptom. If suppose the high horn is damaged, then low and deep horn sound is the function of this particular component. Then fault system would be horn sound is very harsh. Then horn switch, which we have seen, so control the components of horn. If it is damaged, then horn does not sound or always sound. So this, there might be two cases, like whether it is open circuit or the closed circuit. So internally, if switch is open circuit, then you are pressing, then it will not sound, and if it is short circuit, then it will always blow. Then we will see these symptoms in the detail. Then relay is used to switch on the horn circuit after the driver presses the horn switch. So you just give me the reason also, that why we are using the relay here, why we cannot go only with the switch, why we are using the relay. Please comment in the comment box if you know the reason why we are using the relay. This type of question will be asked also, that why we are using the relay here. So horn does not sound or always sound. So this is also the same thing, whether it is short circuit or open circuit. Now fuse. Fuse function is protected device of the circuit, and there might be cases that it will be blown, right? If it is blown, then horn does not sound because it will make the open circuit. Correct. There will be no current flow. Then wire harness. So wire harness is nothing but, you have already seen that when we are going from battery to relay, then we are going first to fuse, then relay, then we are going to switch. So all these are connected through the wiring harness, right? So switch on the basically it is help, or the function of this particular wire harness is switch on the circuit. So the common fault might be open circuit or short circuit. So horn does not sound or always sound. So here also the same type of fault would be there, like open circuit or short circuit. So if you like the content of this particular series or the system, please like, subscribe and comment. In the next video I will tell you about how to do the on vehicle inspection, where we will see the symptoms and what are the suspected area for this particular system. Thank you for your support. Please like, subscribe and comment.